Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to show how to write a force vector in Cartesian form or in unit vector form. So what we're looking at here is we're looking at this 300 Newton force, and this 300 Newton force acts all along this line, the line that points from this point to this point. Now first thing I'm going to do is give these points names here. I'm going to call this point A and this point B. Now, the coordinates of point A, we've got an x, y, z coordinate system. Let's see, it's 1 meter this way, 1 meter back, and 1 meter up. So the coordinates of point A are, let's see, 1, minus 1, and then up 1. So plus 1 in meters. The coordinates of point B, let's see, it's back 1, so we're going to go minus 1. Y direction, we're going this way 1. And then Z direction, it doesn't go up or down at all, so we'll just say 0, Z. All right, so again, these are coordinates in meters. So go ahead and put units on them. And what I'm going to do first here is find the position vector that points from A to B. So that would be a vector that points like this. I'm going to call that position vector AB. Now, when we find these position vectors, remember how we do that. Hopefully you see my videos on how to do this. You just take the difference between the x coordinates, difference between the y coordinates, difference between the z coordinates. So I'm going to go ahead and just put negative 1, minus 1. That's going to be minus 2i. And again, if you're wondering where the negative 2 is, just go back and look at my video on how to find these displacement vectors. Next term is going to be 1 minus a minus 1. 1 minus a minus 1. That's going to be plus 2j. Then the next term is going to be 0 minus 1. So we're going to have minus 1k. And again, I like to put the units out here, and these are in meters. Now, next step here is to find a unit vector in the direction of AB. I'm going to put that in red. So what I'm going to do here is I'm now going to create a unit vector. Call that RAB with a unit vector symbol over it. Now you notice, I probably drew this a little long. First of all, it doesn't even make sense to compare the length of this red unit vector to that 300 Newton force vector. They're apples and oranges, but one is about this length on the graph, so I was trying to make it about that length. But anyway, the way we're going to find that is we're going to take this guy and divide it by its magnitude. So I'll calculate its magnitude up here. The magnitude of position vector AB is equal to the square root of 2 squared plus 2 squared plus 1 squared. And I'm going to go ahead and just put 4 plus 4 plus 1, which is 3. So the unit vector AB, we're going to get by taking the position vector AB and dividing by its magnitude. So that's going to be negative 2/3 I plus 2/3 j plus, minus 1/3 k. This is now a unit vector that points from A to B, exactly parallel to this 300 Newton force. It's a dimensionless vector because we've divided its magnitude out. All this is a direction. I like to think of unit vectors as little pointers. So now what we can do is we can take our force vector, and it's equal to 300 newtons, and it's in this direction. So I'll go ahead and just multiply it by minus 2/3 I plus 2/3 j minus 1/3 k. And again, all we've done now is given it a direction. This doesn't have any units, and it's of length 1. That's why we can do this multiplication without problem. We're not changing anything. So let's see here. I believe that term is going to be minus 200 newtons I. I'm going to put minus 200 I, and I'll put the units later. Let's see. That's going to be plus 200 j. And then that's looking like minus 100k. And again, these are in newtons. So here is our force vector written in Cartesian form, or in unit vector form, minus 200i plus 200j minus 100k. I hope this video helps demonstrate how to give a force vector a direction. Have a great day.